Hello everyone, welcome to the second video lecture of Module 4 Infinite Series and Power Series Solutions of the subject Advanced Calculus and Numerical Methods. In the previous video lecture, we have seen the definition of infinite series and we have discussed few tests on series of positive terms to decide the nature of positive series. That is to decide whether the series is convergent or divergent. In this lecture, I am going to discuss about an important test called Cauchy's root test to decide the nature of given positive term series. First, we will see what the Cauchy's root test is, and then we apply it on a given series to find the convergence. Now, what is Cauchy's root test? Cauchy's root test, or it is simply known as root test, states that in a positive term series summation un, if limit of un power 1 by n as n tends to infinity is equal to lambda, then the series converges if lambda is less than 1 and diverges if lambda is greater than 1. That is, given positive term series summation un, we first find nth root of un, that is we find un power 1 by n, apply the limit to this, that is find the limit of un power 1 by n as n tends to infinity. If this limit is less than 1, then the series converges. If this limit is greater than 1, then summation un diverges. Also note that if limit un power 1 by n as n tends to infinity is equal to 1, then this Cauchy's root test fails. Next, we will take some series and apply this root test to determine whether it is convergent or divergent. Also note that the root test is useful for a series whose nth term is of the form f of n to the power g of n. Now let us solve the problems. So first question is, discuss the convergence of the series summation 1 plus 1 by n whole power n square. Now comparing this given series with the summation un, we have nth term un is 1 plus 1 by n to the power n square. Let us find the limit of un power 1 by n as n tends to infinity. Now substitute for un here. Un is 1 plus 1 by n to the power n square, whole to the power now 1 by n. That is 1 plus 1 by n to the power n square into 1 by n. 1 n cancels, that is we have 1 plus 1 by n to the power n. And we know that this is the standard limit. The value of this limit is equal to e. Limit of 1 plus 1 by n whole to the power n as n tends to infinity is equal to e, and e is approximately equal to 2.72, which is greater than 1. Now by Cauchy's root test, if the limit of un power 1 by n as n tends to infinity is greater than 1, then the series diverges. Here for this series we have limit of un power 1 by n as n tends to infinity is 2.72, which is greater than 1. So we have the given series diverges. Next question. Test for the convergence of the series summation n cube by 3 power n. So we have nth term un is n cube by 3 to the power n. Find the nth root of un and then find the limit of un power 1 by n. That is find limit of un power 1 by n as n tends to infinity. So here we have un is n cube by 3 power n. Next step, we can write n cube power 1 by n divided by 3 power n to the power 1 by n. That is we have n to the power 3 into 1 by n, that is n power 3 by n divided by 3 to the power n into 1 by n. So n cancels there. So we have 3 to the power 1, that is 3. Next, we can write the numerator as n power 1 by n whole power 3. Note this, n power 3 by n can be written as n to the power 1 by whole to the power 3. And next, we are going to apply the standard limit here in the numerator. We have standard limit of n power 1 by n as n tends to infinity is equal to 1. So substituting here, we get the limit 1 by 3, and 1 by 3 is less than 1. So by Cauchy's root test, we have given series is convergent. Next problem, discuss the convergence of the series summation n by n plus 1 whole to the power n square. Here the nth term is un is equal to n by n plus 1 whole to the power n square. Now find the limit of un power 1 by n as n tends to infinity. So substitute for un n by n plus 1 to the power n square whole to the power 1 by n. Then in the next step, here we have n by n plus 1 to the power n square into 1 by n. So we have n by n plus 1 to the power n. Next, inside the bracket, here in the denominator, take n outside the bracket and write n into 1 plus 1 by n and cancel this n. We get 1 by 1 plus 1 by n whole power n. Next, take the limit as n tends to infinity. So limit, apply it on the numerator. So it is 1 power n is 1 only. So we can write 1 by 1 plus 1 by n whole power n and use the standard limit of 1 plus 1 by n whole power n as n tends to infinity. The value of this limit is equal to e. So here substituting, we get 1 by e. So 1 by e is approximately equal to 0.37. You can use the calculator and you'll get 1 by e is approximately equal to 0.37, which is less than 1. So by Cauchy's root test, given series summation un, that is summation n by n plus 1 whole to the power n square, is convergent. Let us go to the next question. Test for convergence of the series 1 plus 1 by root n whole to the power minus n power 3 by 2. So un is 1 plus 1 by root n whole power minus n power 3 by 2. Limit of un power 1 by n as n tends to infinity equals to limit as n tends to infinity. This is un to the power 1 by n. Next step. This is equal to limit as n tends to infinity 1 plus 1 by root n to the power n to the minus 1 plus 1 by root n to the power minus n to the power 3 by 2 into 1 by n. That is, we can write n power 3 by 2 into 1 by n. 1 by n can be written as n to the power minus 1. So it is n power 3 by 2 into n power minus 1. That is n power 3 by 2 minus 1. That is n power half. Okay, so we have this is equal to 1 plus 1 by root n to the power minus n power half. Now n power half is nothing but root n. So we have we can write in the form 1 by take n minus root square root of n to the denominator. It becomes positive. Minus square root of n becomes positive. So here 1 by 1 plus 1 by root n to the power root n. Next, apply the standard limit. Limit 1 plus 1 by n whole power n is, we have e. Now in place of n we have root n, and note that as n tends to infinity, root n also tends to infinity. So the value of this limit is also equal to e. So in the denominator we have e and numerator 1. So 1 by e approximately equal to 0.37, which is less than 1. So by Cauchy's root test, the series, given series is convergent. Next problem, test for convergence of the series summation log n power minus 2n. So here un is log n power minus 2n, limit un power 1 by n as n tends to infinity equals to limit of log n power minus 2n to the power 1 by n as n tends to infinity, that is log n to the power minus 2n into 1 by n. So we have log n power minus 2. We can write 1 by log n power plus 2. So we have this and put n equal to infinity. We have log infinity is infinity, so we get 1 by infinity, that is 0, which is less than 1. So by Cauchy's root test, the given series is convergent. Next question, test for convergence of the series 2 square by 1 square minus 2 by 1 whole to the power minus 1 plus 3 cube by 2 cube minus 3 by 2 whole power minus 2 plus 4 power 4 by 3 power 4 minus 4 by 3 to the power minus 3 plus and so on. So here note that nth term of the series is not even. First we have to write the nth term of the series. Look at the given terms carefully. First term is 2 square by 1 square minus 2 by 1 to the power minus 1. Second term is 3 cube by 2 cube minus 3 by 2 whole power minus 2. Okay, and so on. So here we have minus 1, minus 2, minus 3. So in general or in nth term we will be having minus n. And here in the denominator we have 1 square, here 1. Here in the second term we have 2 cube and here 2, and third term 3 power 4 minus 3. So in general we will be having n power n plus 1 and here n. Okay, so and numerator will be having n plus 1 to the power n plus 1. So we have, this is the general term un. We can verify. Put n equal to 1, we will get the first term. Put n equal to 1. So 2 by 1 to the power 2 minus 2 by 1 to the power minus 1. So we get the first term. Take n equal to 2. 3 by 2 to the power 3 minus 3 by 2 to the power minus 2, which is the second term. So we have this, the nth term. Find the limit of un power 1 by n as n tends to infinity. Substitute for un this whole to the power 1 by n. So we have minus n into 1 by n. So we have minus 1. Next step, we can write n plus 1 by n power n plus 1 as n plus 1 by n to the power n into n plus 1 by n. N plus 1 by n to the power n into n plus 1 by n. And n plus 1 by n, second term, right, as it is. Okay, next. Here inside the bracket we can write n plus 1 by n, we can write as, we have n by n plus 1 by n, that is we have 1 plus 1 by n. Here also n by n plus 1 by n, that is 1 plus 1 by n. And here also n plus 1 by n, write it as 1 plus 1 by n. Now apply the limit. We have standard limit. Limit of 1 plus 1 by n whole power n as n tends to infinity is equal to e. This is e, and we put, if you put n equal to infinity here, this becomes 1 by infinity 0. This is 1 into e. So this is e minus, and this is 1 by infinity 0. So we have, this is 1. So it is e minus 1 to the power minus 1. Use calculator. We get 0.58. So the value of the limit is un, limit of un power 1 by n as n tends to infinity is 0.58, which is less than 1. So the series is convergent. Now let us move to the next problem. Discuss the convergence of the series half plus 2 by 3 into x plus 3 by 4 whole square into x square plus 4 by 5 to the power 3 x cube plus etc. Here also nth term of the series is not given. We have to first find nth term un. Note that sometimes it is not easy to find the general term or nth term of the series if we consider all the terms of the series. Also note that addition or removal of some finite number of terms will not alter the nature of the series. So here, leaving the first term, we can easily write the nth term. Note that here we have, if we leave the first term, so this will be our first term. Here we have 1 x power 1, and this will be second term, this will be our second term, so x power 2, third term x power 3, in general x power n. In the nth term we will be having x power n. Next, here we have 2 by 3, okay, and here 3 by 4 whole square, etc. In general, if it is n here, then it is n plus 1 by n plus 2 whole to the power n. So this is our general term. Next, find the limit of un as n tends to infinity. Find the limit of un power 1 by n as n tends to infinity. Substitute for un, limit of n plus 1 by n plus 2 to the power n, x to the power n whole to the power 1 by n, that is here n plus 1 by n, n plus 2 to the power n into 1 by n, that is we have n plus 1 by n plus 2 to the power 1. Similarly here x power n into 1 by n, that is x power 1. So we have, this is n plus 1 by n plus 2 into x. Now here from the numerator and denominator we can take n outside the bracket, and cancelling n we get 1 plus 1 by n, 1 plus 2 by n, and now apply the limit. 1 by infinity is 0, 2 by infinity is 0, so we get this is 1 and 1 into x. So the limit is x. Limit of un power 1 by n as n tends to infinity is equal to x. Now by Cauchy's root test, series converges if the limit of un power 1 by n as n tends to infinity, if this limit is less than 1, and diverges if the limit is greater than 1. So we have the series converges if the limit, that is if x is less than 1, and diverges if x is greater than 1. And the test fails for the case if we get the limit un power 1 by n as n tends to infinity equal to 1, then the test fails, that is the test fails if x equal to 1. Okay, so we'll find the convergence of the series for x equal to 1 separately. We apply some other test. Okay, now look at the series when x equal to 1. What is un? Now when x is equal to 1, un is equal to n plus 1 by n plus 2 whole to the power n into 1 power n, that is n plus 1 by n plus 2 whole to the power n. Find the limit of un as n tends to infinity, that is limit of n plus 1 by n plus 2 whole power n as n tends to infinity. Now here inside the bracket take n outside, and outside from the numerator and denominator, and cancel n. Okay, so you have 1 plus 1 by n by 1 plus 2 by n whole power n. We can write it as limit of numerator, that is limit of 1 plus 1 by n to the power n divided by limit of 1 plus 2 by n whole power n. Apply the standard limit. We have limit of 1 plus x by n whole power n is e power x. Okay, limit as n tends to infinity of 1 plus x by n whole power n is e power x. Now apply this standard limit for the numerator. We have, it is e power 1. In place of x we have 1, so e power 1, and in the denominator we have in place of x we have 2, right? So this is e power 2. So we have e by e power 2 or 1 by e. 1 by e is a finite quantity not equal to 0. So we have from the test for convergence of a positive term series, if limit of un as n tends to infinity is not equal to 0, then we have the series, the given series is divergent. So we have summation un, that is for the case when x equal to 1, the series is divergent. Okay, so we can combine these two results together and we can write, hence the given series is convergent for x less than 1 and divergent for x greater than or equal to 1. Okay, so this is the conclusion. So we have completed Okay, with this we have completed problems on Cauchy's root test. In the next video lecture, we will discuss one more important test on series of positive terms called D'Alembert's ratio test. Thank you.